Can I play?
Who's this nerd? Who are you, punk? Have you ever played basketball before, kid?
I've played all my life. Why?
Then dunk it.
Okay.
That's why. This time it's done.
Oh, I better go.
Are you just as bad as this young man? Yeah, I thought so. Do you want to be able to dunk just like the pros? Yeah, I thought so. Well, here's a product just for you. Our UltraDunks. These specially designed shoes feature newly patented nitrogen gas fuel technology that can add over a meter to your current jump. Let's go meet the creators of the UltraDunks for an in-depth look at this great product. Welcome to the lab!
These are the amazing UltraDunks. These specially designed shoes have chemical reaction systems right in the heel of each shoe. The chemical reaction is ignited from a spark, which is triggered from a remote control button. The reaction releases nitrogen gas through these two thrusters at amazing speeds. The gas packs enough punch to propel a 160 kilogram male or female up 1 billion nanometers.
Exactly, and in fact, our UltraDunks work just like instant ice packs. Instant ice packs contain a compartment of ammonium chloride that is separated from water that, when broken, absorbs heat as it dissolves, just like this. The heels of our UltraDunks contain the same three reactants used in airbags that, when sparked by the button you push, react to expel gas as they mix.
I'm sure our viewers are very interested in this remote control button. Can you explain more about it?
Of course, our remote control button, which you can conveniently attach to any part of your body, sets off a spark in the heel by pressing the middle button, as you can see. The energy for the spark is supplied by a AA battery embedded directly in the shoe. And this spark is a spark that supplies the sufficient activation energy needed to kickstart the reaction of our three chemical reactions.
The reaction then becomes self-sustaining since it's exothermic.
Ooh, thermodynamics! I love it! Tell me more about it.
So the first reaction we have is sodium nitrate forming solid sodium and nitrogen gas. Pizza formation will give us an enthalpy of negative 43 kilojoules per mole.
Exothermic.
Which means it can supply its own activation energy, which means it's self-sustaining.
And since it's the same chemical reaction used in airbags, we know it's spontaneous.
Ah, but are you sure? What about the thermodynamics?
Fine. You could use Gibbs's free energy of formation.
To discover that the reaction has a delta G of negative 187 kilojoules per mole.
By now, I can see it in your eyes that you're worrying about our reactions with products. You're saying sodium is a highly reactive alkali metal, which means it could explode on contact with water.
Not to worry, my friends. There's also a second reaction that consumes the sodium. It's sodium reacting with potassium nitrate. They both form potassium oxide and sodium oxide and nitrogen gas.
Wait, what about the thermodynamics?
The enthalpy, the heat of formation gives us an enthalpy of negative 1550 kilojoules per mole.
Exothermic.
Self-sustaining.
Ah, but wait. Our viewers are now worried about this reaction's products. Potassium oxide and sodium oxide. Oh my!
Indeed. In fact, upon contact with water, these chemicals create bases so strong that they can dissolve your foot.
Acids and bases, I love those too.
Oh, lovely. So any alkali oxide reacts with water to create the hydroxide ion and the alkali metal ion.
And since these are effectively alkali hydroxides dissolved in water, the products are all strong bases.
Exactly. The reaction is metal oxide plus water forming metal ions and hydroxide. So each mole of alkali oxide creates 2 moles of hydroxide upon contact with water.
Then, To create a solution of 13.0, the pH of a typical bleach, we need a pOH of 1.0. That's a concentration of 0.1 molar.
Then suppose a single drop of water, about 0.5 milliliters, dissolves the alkali oxide. 0.5 milliliters of a 0.1 molar solution. That's about 5 times 10 to the negative 5 moles of hydroxide. So at a 1:2 ratio, that's only 2.5 times 10 to the negative 5 moles of alkali metal oxide needed to create a base strong enough to dissolve your foot.
How dangerous.
My friends, not to worry. There's a third reaction that consumes the 3 oxides. Potassium oxide, sodium oxide, and silicon oxide all form glass.
Glass?
Yes. Glass is simply silicates spiked with potassium and sodium. Remember, silicates spiked with alkali metals are just ceramics. So the products of the reaction are just ceramics and glass.
But glass?
And what about the thermodynamics?
They're just small beads, just like sand.
Ah,
I see.
so that's perfect for splitting up opponents on courts.
That's right. And though we can't use heat of formation here since the products are ambiguous,
We know it's spontaneous since the reaction is used in airbags.
Nice.
Take an in-depth look at the UltraDunks heel. As you can see, this is the spark that ignites the first reaction, which includes sodium nitrate. The second reaction includes this reactant, which is potassium nitrate. The third reaction includes silicon oxide.